Deep beneath our feet, buried in rock layers 65 million years old, scientists have discovered something that should not exist. Microscopic spheres of rare metals scattered across the globe in a pattern that mirrors exactly what we see from modern nuclear testing. But these spheres predate human civilization by an impossible margin. We have always believed we were the first species to split atoms, to melt metals, to burn fossil fuels, and change our planet's atmosphere. But what if we were wrong? What if Earth has hosted advanced civilizations before and geological time simply erased every trace of their existence? Today, we journey through evidence that challenges everything we thought we knew about our planet's history. We will explore vanished nuclear signatures, examine mysterious mass extinctions, and investigate why the fossil record contains such enormous unexplained gaps. Prepare yourselves. We begin. Music. In 1980, geologist Walter Alvarez was examining rock layers in Italy when he found something extraordinary. A thin clay band marking the boundary between the Cretaceous and Paleogene periods contained levels of iridium 30 times higher than normal. This rare metal is abundant in asteroids, but virtually absent from Earth's crust. The discovery revolutionized our understanding of mass extinctions. That iridium spike became proof of the asteroid impact that killed the dinosaurs 65 million years ago. But what fascinated scientists most was how clearly this single catastrophic event left its signature in the geological record. This revelation sparked a troubling question. If one asteroid impact could leave such obvious traces after 65 million years, what signatures would an advanced technological civilization leave behind? And more importantly, would we even recognize them? The Silurian hypothesis emerged from this thinking. Named after an ancient species from Doctor Who, this scientific theory asks whether industrial civilizations could have existed on Earth long before humans, leaving behind traces so subtle or so transformed by geological time that we simply haven't recognized them yet. Consider the scale of deep time. If human industrial civilization lasted 10,000 years and then vanished, that period would represent just 0.2% of Earth's 4.5 billion year history. Finding evidence of such a brief period would be like searching for a single page in a library containing 4 million books. But evidence should exist. Every industrial civilization must consume energy, alter atmospheric chemistry, and produce waste products that persist far longer than buildings or machines. These signatures become part of Earth's permanent geological record, preserved in rock layers, ice cores, and sediment deposits. The challenge lies in recognizing these signatures. We know what modern industrial activity looks like because we are creating it right now. We pump carbon dioxide into the atmosphere, scatter plastic particles across the globe, and produce radioactive isotopes that will persist for thousands of years. Future geologists would easily identify our impact on the planet. But what if previous civilizations used different technologies? What if they harnessed energy sources we haven't discovered or developed materials that decay differently than our plastics and concrete? Their industrial signatures might be hiding in plain sight, misinterpreted as natural phenomena. The iridium layer proves that Earth preserves evidence of dramatic events across vast spans of time. If the planet can maintain a record of a single day when an asteroid struck, it should also preserve traces of civilizations that might have thrived for millennia. Scientists began examining the geological record with new eyes, searching for patterns that might indicate ancient industrial activity. What they discovered challenges our most fundamental assumptions about life on Earth. The evidence starts with a mystery buried in Earth's fossil record. Earth's fossil record should tell the complete story of life on our planet. Instead, it reads like a book with most of its pages ripped out, leaving behind fragments that hint at chapters we cannot read. Paleontologists call these missing sections gaps, but that word fails to capture their staggering magnitude. The Cambrian explosion 540 million years ago sees complex life forms appearing suddenly in the fossil record as if someone flipped a switch. Before this event, we find mostly simple single-celled organisms. After it, the oceans teem with creatures possessing eyes, shells, and sophisticated body plants. This transition should have taken millions of years of gradual evolution. Instead, it appears to have happened almost instantly in geological terms. The fossil record offers no explanation for this dramatic leap in complexity. But the Cambrian explosion represents just one of several mysterious gaps. The fossil record contains multiple periods where life seems to advance in sudden, unexplained jumps. Species appear, thrive, then vanish without obvious causes. New forms of life emerge fully formed as if they materialized from nowhere. Traditional explanations point to preservation bias. Soft-bodied organisms rarely fossilize, so we might be missing crucial evolutionary intermediates. Environmental conditions affect fossilization rates, creating apparent gaps where gradual change actually occurred. These factors certainly contribute to the incomplete record. However, some gaps seem too systematic, too precisely timed to result from random preservation failures. They coincide with dramatic changes in atmospheric composition, ocean chemistry, and global climate patterns that suggest something beyond normal evolutionary processes was occurring. Consider the Great Oxygenation event 2 billion years ago. Oxygen levels in Earth's atmosphere suddenly increased dramatically, poisoning most existing life forms while enabling new types of organisms to evolve. This transformation fundamentally altered the planet's chemistry and biology. Scientists attribute this event to cyanobacteria beginning to produce oxygen through photosynthesis, but the timing and scale of the change seem remarkably precise for a natural process. The oxygen increase follows a pattern that resembles what might happen if an advanced civilization began large-scale manipulation of atmospheric chemistry. Similar patterns appear throughout the fossil record. Periods of stability interrupted by sudden dramatic changes that reshape life on Earth. Mass extinctions followed by rapid diversification of new species. Chemical signatures in rock layers that suggest massive coordinated alterations to planetary systems. These patterns could result from natural processes we don't fully understand. Earth's climate and chemistry operate through complex feedback loops that might produce sudden transitions under certain conditions. But they could also indicate something else entirely. What if some of these gaps represent periods when previous civilizations dominated the planet? Their industrial activities might have altered environments so drastically that most existing species went extinct, creating apparent gaps in the fossil record. The rapid emergence of new life forms might represent either evolutionary responses to changed conditions or evidence of genetic manipulation by advanced beings. The rock layers themselves contain even stranger evidence. Every factory, every power plant, every piece of heavy machinery leaves chemical fingerprints that persist long after the structures themselves crumble to dust. These signatures become incorporated into Earth's geological record, creating permanent evidence of industrial activity that can survive for millions of years. Modern industry produces distinctive isotope ratios that differ dramatically from natural processes. When we burn fossil fuels, we release carbon that has been locked underground for millions of years. This ancient carbon has a specific isotopic signature that shows up clearly in atmospheric measurements and gets preserved in tree rings, ice cores, and marine sediments. Nuclear weapons testing created radioactive isotopes that appear nowhere in nature. These artificial elements will remain detectable in geological samples for thousands of years, providing future scientists with unmistakable proof that an advanced technological civilization existed on Earth during the 20th and 21st centuries. But here is where the mystery deepens. Geologists have discovered similar anomalous isotope signatures in rock layers that predate human civilization by millions of years. The Permian-Triassic boundary, marking the Great Dying 252 million years ago, contains carbon isotope ratios that mirror exactly what we see from massive fossil fuel combustion. The scale of this signature suggests an event that released carbon equivalent to burning all known coal, oil, and natural gas reserves on Earth within a relatively short geological time span. Traditional explanations invoke massive volcanic eruptions or methane releases from warming OCE atmospheric samples stretching back 800,000 years. Within these samples, scientists have identified periods of rapid atmospheric change that resemble what we might expect from large-scale industrial activity. Concentrations of greenhouse gases spike suddenly, remain elevated for thousands of years, then return to baseline levels. These patterns appear multiple times throughout the ice core record, always preceded by subtle changes in atmospheric chemistry that suggest coordinated manipulation of planetary systems. The changes are too rapid and too systematic to result from known natural processes. Rock formations in Colorado contain microscopic spheres of titanium and other rare metals arranged in layers that correspond to specific time periods. These spheres are identical to particles produced by high-temperature industrial processes. Yet they appear in geological strata that formed long before humans developed metallurgy. Similar metallic anomalies have been discovered in sediment cores from deep ocean basins. The metals are distributed in patterns that suggest widespread atmospheric dispersal, as if they were released by numerous industrial sources operating simultaneously across different continents. Ocean sediment cores reveal additional evidence of ancient industrial activity. Layers of sediment contain concentrations of synthetic compounds that should not exist in nature. Yet they appear in geological contexts that predate human chemistry by enormous margins. These chemical signatures could have natural explanations we haven't yet discovered. Earth's geological processes are incredibly complex, and we may be misinterpreting evidence of unusual but natural phenomena. However, the patterns are becoming too numerous and too systematic to ignore. The evidence extends beyond chemistry into the realm of materials that shouldn't exist at all. Plastic will be humanity's most enduring legacy. Long after our cities crumble and our bones turn to dust, microscopic plastic particles will remain embedded in sediment layers, providing future geologists with unmistakable evidence that an industrial civilization once dominated this planet. Plastic breaks down extremely slowly in natural environments. Even when exposed to sunlight, heat, and chemical weathering, plastic fragments persist for hundreds or thousands of years. In deep ocean sediments or frozen environments, plastic could remain virtually unchanged for millions of years. This durability makes plastic an ideal geological marker. Future scientists examining Earth's sediment layers will discover a sharp transition where plastic particles suddenly appear in enormous quantities, marking the beginning of what geologists might call the Anthropocene epoch, the age when humans began reshaping the planet through industrial activity. But recent discoveries suggest we might not be the first civilization to leave such markers behind. Sediment cores from remote ocean basins contain microscopic particles of what appears to be synthetic polymer compounds in layers that formed millions of years before humans invented plastic. These particles display characteristics identical to modern plastic fragments, including resistance to natural degradation processes and chemical compositions that don't occur in nature. The particles appear in discrete layers separated by millions of years, suggesting multiple episodes of widespread synthetic material production, followed by complete cessation of the activity. The distribution patterns indicate global dispersal, as if these materials were being produced and used by a planet-wide civilization. Advanced analysis reveals even more puzzling details. Some of these ancient polymer fragments contain molecular structures that represent improvements over modern plastic technology. They show evidence of engineering designed to enhance durability and resistance to environmental breakdown, suggesting their creators possess sophisticated understanding of material science. Deep drilling projects in Antarctica have recovered ice samples containing similar synthetic particles in layers that formed hundreds of thousands of years ago. The particles are perfectly preserved in the ice, maintaining their original molecular structure and providing clear evidence of their artificial origin. These discoveries challenge everything we thought we knew about materials, science, and planetary history. Either natural processes can somehow create perfect polymer mimics under conditions we don't understand, or previous civilizations developed advanced chemistry long before humans appeared on Earth. The timeline implications are staggering. If these particles really represent evidence of ancient industrial activity, then technological civilizations have arisen and vanished multiple times throughout Earth's history. Each episode left behind its characteristic signature in the geological record before disappearing completely. Rock formations in Australia contain layers of what geologists initially identified as unusual mineral deposits. Closer examination revealed these minerals to be degraded fragments of synthetic materials with complex molecular structures that required advanced manufacturing techniques to produce. Carbon dating of organic material found alongside these fragments indicates ages that stretch back millions of years. Yet the synthetic compounds show no signs of the degradation that should occur over such vast timescales. This preservation suggests either unknown natural processes or manufacturing techniques that far exceed current human capabilities. The evidence forces us to confront an uncomfortable possibility. We may be walking across the ruins of previous civilizations without even recognizing them.